Greetings, everybody. This is Timur. Apologies, we're running a little late today on starting this webinar, but now we're ready to go. And welcome again to this webinar series that we run on a monthly basis. Today, we're going to be speaking about starting with the exabyte platform and migrating your existing assets into it. The goal of this seminar is to help users understand the workings of the exabyte.io platform. Now is the third Friday of the month, and that's when we speak about advanced topics. Every participant here should be a registered user, and everybody will receive a copy of this presentation and the recording as well. If you have questions at any time, please use Zoom functionality to ask those questions. We'll have specific time to answer them. We will assume that the users here are familiar with the basics of computational material science tools like Quantum Espresso, VASP, or similar, and the basics of Linux operating systems. We will explain how to migrate a set of established scripts that they might be using today with tools like Quantum Espresso and VASP, how to migrate those scripts to the exabyte platform. And for those, we will speak about two options. Either we can bypass the user interface and use command line and collaborate with that. It's a quick and easy way to start, but it's error prone and it's difficult to collaborate this way. Or the second option would be to adopt the exabyte.io approach, create the required entities like materials, workflows, and jobs, and utilize the full functionality of the online platform. Similarly, the collaboration is also can be twofold. It also can be twofold. We can either use the file system to collaborate through command line, or we can use the exabyte platform to the fullest extent of it and collaborate online. This is the agenda for today. We'll talk about the platform infrastructure, and then we'll switch to materials, workflows, jobs, and cover collaboration at the end. At any time, the webinar participants can request to join the webinar account. And this account has advanced features for collaboration that you can test drive. And we'll welcome your feedback, and we will be glad to work with you if you have any additional requests there. All right. Now let's start with the platform infrastructure. Here is the picture of the distributed web application that represents the exabyte.io platform. And as you can see, at the user-facing part of it, we have multiple components that can serve as the entry points. First and foremost, it's the web interface itself, where everybody can connect in using a web browser. And then through the web interface, we can get through to the login node. That's the secure shell-based connected endpoint, and we can use remote desktop and the web terminal to connect to the login node as well. And those three represent the alternative connection methods that we can utilize to bypass the web interface. We can also use the RESTful API, but we will not speak about the RESTful API in today's session. To be able to connect through the secure shell SSH, we're going to need to upload a key and connect through any terminal, like Mac OS terminal or PWC. With the web terminal, we don't have to upload anything. We just have to log in, select the right-hand sidebar, and click terminal. That's where the connection is established, and then it's a familiar secure shell interface. We can upload and download files by dragging and dropping information into the window, and there is also a copy-paste dialog that can be opened through Ctrl-Shift-Command. On the remote desktop, we can utilize the graphical interface for Linux operating system, and we can open it in the equivalent way. We open the right-hand sidebar first and select the remote desktop. And that's how we can use additional tools like Vesta or Xquestion to do visualization and analysis. To be able to collaborate, we need to understand how the file system is arranged for the login node. And we do that by providing file system access to multiple computational clusters, and these clusters could be hosted on multiple cloud providers. And we accommodate thereby the flexibility to be able to utilize all these different cloud systems. For example, in production now we have cluster 001, and users that log in to the login node will see through one out of three scenarios, either through SSH, through a remote desktop, or web terminal. We'll see that there are links to the production clusters inside their home folder. And if they navigate inside those links, they'll be able to see the corresponding file system. And inside that file system, we have links to organizational accounts, like I'm a member of exabyte.io account, so we have a computer-friendly exabyte-io and a named link inside cluster 001 home folder. There's also a set of other links that I'm going to explain right now. The Dropbox folder is accessible anywhere in the system, and it's used as a hot cache storage. So when we want to share scripts, small data below 1 gigabyte, things like source code or some small amounts of information from city potentials, for example, we can drop them into Dropbox, and they will become available both on the login node, on the master node, and on the web interface. The user data folder is where we accommodate all the calculations that are started on the web interface, and we organize them in a particular fashion. You can read on about this online, but long story short, if we have a user named Steven, a project named default, and a job named new job November 11th with a date, and it has an ID in the database, then we stitch all of this together to create the final name inside the data folder. And the similar approach is used for organizational accounts. Now, this data folder can be useful when we want to do analysis with tools like XKristen and other visualization tools that we provide to remote desktop. We can utilize those to understand what happened in the calculation, in addition to the tools that we have on the web application. So, a remote connection has an alternative to the main browser-based web connection, and we can enable that upon request. It's available to certain service levels. We have three options: web terminal, remote desktop, and a secure shell. And with this connection, we're connecting to the login node, and then through that to multiple computational clusters. To be able to run command line jobs, we have to be inside one of these clusters. We have to navigate into the file system of one of these clusters to tell the scheduling system which cluster we want to use. Otherwise, it won't be able to understand that. And there's a variety of software packages that are available through remote desktop or through command line module. If there are no questions yet, I'll skip and continue on with the materials. Let's assume now that we have two input files for Quantum Espresso that represent a particular workflow that extracts the information about the electronic structure. And let's understand how we can migrate this information first to create a material, and then to migrate the workflow calculation logic as well. So first, let's inspect these two files. We understand that they contain material information, they contain the structural information inside, and they also have some logical components like the type of calculation, self-consistent field, non-self-consistent field, and things like that. So our first step would be to, in creating a new material, our first step would be to understand the content of the input files, the relevant content, like the cell parameters that are represented in atomic coordinates, and atomic positions here that are given in crystal coordinates. Then we navigate to the list of materials, click the plus button, and initiate the materials designer session with a default material. In this case, it's silicon FCC. which we copy and then remove the original one to avoid affecting the database entry. And now this stem cell material, the material that we're going to be using to migrate the information, we changed the name for. All right, so now we are ready to start editing the structural parameters. The second step for us is to open the Crystal Lattice dialog, and inside the Crystal Lattice dialog, we select triclinic as lattice type, and then migrate the lattice parameters. So we can migrate lattice parameters in angstroms, A and B, and then we get the lattice parameter C as well. Populate the values. It's going to be 90 degrees for all the angles, as we can infer from the original structure. And here we go. That's the crystal lattice. That's its representation. The next step after that is to migrate the crystal basis information, and that's an easy step because we already have it in crystal coordinates. All we have to do is just to copy paste. So we copy information from original file and paste it into the crystal basis dialog. And now we can see that the structural information has been migrated. The last step is to save this file, and we open the input-output menu at the top, click Save, enter a tag from PWSCF to be able to find this entry in the database in the future, and click OK. After the loader has finished spinning, we can see that there is a notification that's shown in green, denoting success. And if we exit the session now, we can see the material in the list of materials. This is the newly created entry. All right, so that's how we migrate the structural information from Quantum Espresso input file to an exabyte entity. We can also migrate it by using an online conversion tool, like the one that I'm demonstrating here, converting Quantum Espresso input file into PostCar, retaining only the structural information, and then using PostCar file directly to upload the data. And we have covered this topic in one of the Getting Started webinars earlier. Now, how do we go about migrating the data that represents the calculation logic? To do that, we have to understand the logic first. And here we have two files that are connected in a simple succession. Right? First, we run a SCF calculation and then non-self-consistent field part. And we have to understand the relevant system parameters, like the parameters for the wave functions cutoff and sampling for the key points. And once we know those parameters, once we keep track of them, we should be ready to create a workflow inside the Exabyte platform. For that, we go to the list of workflows, click the plus button, and here we are presented with an empty workflow session, empty workflow instance. Our next step is to set up the naming. We call this new workflow from PWSCF input. We change the name of this first sub workflow, first and the only, SCF and SCF. And then, as we can see, it's already pre-populated with Quantum Espresso as the application, so we don't have to change anything there. What we do is we add a unit instead to the sub workflow. And again, by default, the first unit is added as PWSCF as a flavor. Now, if we click on that unit, we now can change and see all the flavors available for PWSCF calculations. pw.x as an executable has multiple flavors, and here they are listed. We can see the properties that we extract, and we can see the initial templating and the keywords that we have inside the input file. Some of them are different from the ones that we have in our input file. So what we would have to do is to come into the original input file and copy them and replace the ones that are different. This is what I'm going to do here. Right, for all the namespaces, I'm selecting the keys that are different, pasting them, and removing the ones that are not present in the original file. Right? After we're done with this process, we can preview the template using the template data, which again comes from the default material, silicon FCC in this case. And if we preview it, we can see that the structural information is now pre-populated. Instead of Jinja template variables, we see the actual structural information. And we can verify that it looks the way that we want it to. Excuse me. So that's how we have migrated the logical information, the workflow information for the first unit. Now we do the same the second time. We add additional unit to the sub workflow. This time we select flavor to be a non-self-consistent field, and SCF calculation type is adjusted accordingly in the template. And we migrate the rest of the data. Again, for the control, for the system, and for the electrons namespaces, name lists. Okay. So this might look like a laborious and tedious process, which it is. However, the good side is that we only have to do this once. And when we have this workflow ready, the templating part allows us to apply this workflow to multiple materials. So instead of scraping out and replacing the materials information from the input files, we can combine the workflow with one or multiple materials, which I will demonstrate how we can do in the job. And once we've set up the workflow logic, it becomes reusable. And that's the powerful feature of our platform. Step 6 in the succession is to save the workflow. We can change the name, we can add metadata again into it and click Save button at the top. And here we go, we have the workflow entry ready in the list at the top. Right? So that's how we migrate the workflow information containing 2 items from the initial 2 input files to the workflow inside the exabyte platform. Now, a second option, we previously started with an empty copy and an empty instance of a workflow. We have another option as more and more people join and use our platform. They create workflows in our system, and we track the unique entities. And there are available, some of them are available inside the workflows bank. So instead of starting with a default empty workflow session, we could try and find a workflow which already extracts the property that we are interested in. So here I'm navigating to the workflows bank and searching for the band structure workflow. And then I'm copying this workflow to my account. And then we can continue with an equivalent process where we start not from an empty session by starting the workflow designer session, but we start with a workflow that extracts this property that comes from, say, curator's account in the exabyte platform. That's what we endorse first. So import materials and workflows that are curated by the curator's account. And those usually are high quality. We monitor them, we curate them at exabyte.io team. Okay. No questions so far, so let's continue with the jobs. Now that we have materials and workflow information, we can start and create a simulation. We can do that through the command line, and I covered that aspect before in one of the Getting Started tutorials, Getting Started seminars. So we'll omit it from today's discussion and instead focus on how we can create material through the user, where we can create the job through the user interface using the assets that we have just covered, the material and the workflow. So these two would be the required prerequisites to create the material and the workflow. And step 3 would be to create a job and select this material and the workflow inside it. To create a job, I need to first navigate to the project. I cannot create a job right on from the list of jobs. I need to navigate to the project. And projects are useful for organizing multiple jobs and for tracking accounting as well. So once we navigate to the project page and click on the plus button there, we open, this is the project page I'm in right now. Click on the plus button, and I'm opening the job designer, which contains multiple tabs. In the materials tab, I'm also changing the name of the job at the top in the header, and I'm selecting the drop-down, which allows me to select materials. Click select materials. I can now choose the one that I have just created, and then I proceed with equivalently with selecting the workflow that I just created. Okay, so that is the workflow and material initiated inside the job designer. Now, step number 4 is to inspect the workflow and adjust the input file parameters. So sometimes the default parameters that we use might not be the ones that you would like to retain. For example, in this case, the key point sampling is different from the original one. By default, we use the key point per reciprocal atom value of 2000, which amounts to 5 by 5 by 5 uniform grid in this case for this system. But the original grid was 4 by 4 by 2, and the key point grid for NSCF was different as well. So what we do is we navigate to the important settings tab and change the corresponding form values. So instead of 5 by 5 by 5, we have 4 by 4 by 2 and 8 by 8 by 6. Right? When that is done, we now can be sure that the values inside the input templates are going to correspond. Step number 3 is to set up the computational parameters, and that's an important and topic worth discussing much longer, but long story short here, we can select the maximum amount of time that this job is going to be able to run. And in order to not to overspend on it, we make it a hard limit. So pay attention to it. We start with hours. So 1 hour, 0 minutes, and 0 seconds. So 1 total hour is what we put there by default. Then we can select a different computational cluster, which could be hosted by different cloud providers. So we support Amazon Web Services here and Microsoft Azure and other providers as well. Then we can select the different computational queues, which have different ways to schedule the resources. Some of them come very quickly, within seconds. For some of them, the resources will require a little bit of a wait while we configure and request the resources from the cloud providers. Here, for most of the production type calculations, I would recommend ordinary regular to start with. And for the cluster 001 on Amazon Web Services run on C4 instances, we would put 18 cores as a default value. And then I select to be notified when the job is updated in any way. And then I click Save to save this job. When it's finished, I now am presented with the job entry inside the project. And I can run it by selecting the dropdown for this corresponding entry and clicking Run. Right? So what happens after? The job is submitted. It changes the status from pre-submission to submitted. And then within a couple of minutes, it changes the status to active. And that's when we can navigate into the job and see the progress. We can see which workflow, which sub-workflow unit and which sub-workflow unit is currently active. And that unit is highlighted in orange. If you click on it, we can see the output files posted in the real time and updated in the real time graphs of the convergence as well. Okay. So if you exit from here, click on the cross button in the top right corner, you see that the first part of the calculation is done, the SCF part, and then the NSCF part continues on for about 15 minutes or so. All right, and after that, we are presented with the result. So at the end, we have both of these units successfully completed. We can view the results at the top. There is a tab now, in addition to materials, workflow, and compute tabs. We now have results and files tab, which contain exactly those. So at the top, we can see the results that are arranged by unit. So PWSCF has its own results that we extract, and PWSCF has its own. And then to the right, we have the list of files that we can preview or download, just like we would normally in our local system. All right. So that's how we run a job. And if you want to see the charges that we have incurred, we can come back to the compute tab and get to the cost field and then click on it. It will take us to the billing page, and we can get specific value for the current job. Okay, an optional point that I wanted to discuss here is about sharing. It's how we can share this job. In this particular example, I've been using the webinar account to do these calculations, and now the job belongs to the webinar account, but I would like to be able to see this job when I'm logged in as Timur, when I'm logged in under my personal account. And so to do that, I'm going to share it with my personal account right now. I'm going to select the entry, the dropdown for it, and then click the share option inside it. Okay, and here I'm selecting myself and the list of people and the accounts that I can share this entry with. And then I select read option above. Okay, so now my account will have the read permission on this specified entry. And as we can see here in the list, this entry now is shared. All right, so that's how we can share the entry between multiple accounts. So here is a quick summary about the command line jobs. Command line jobs and user interface jobs as well. Command line jobs are a quick way to start and can be familiar to many. So if you have input files for Quantum Espresso, you can log into our system through a secure shell and reuse those files and utilize environment modules to be able to use the high-performance computing infrastructure that we assemble. And you will be required to modify the input files each time any job is created. And we will only be able to store the data on disk. So the connection to the database and collaborating on the information that you're producing is non-trivial. For the jobs that are created on the user interface side through our platform, we can work with multiple materials at the same time. Right? Once we migrate the information from the input files to the workflow item, we can apply the logic to multiple materials. We can organize the data in database, which comes at no cost to the user. It comes included. And we can enable collaboration, sharing the data between multiple accounts. Most of the time, our workflow as computational scientists include just a handful of different logical sequences. And once we have those established, we can repeat those for a large set of materials. And that's where the power of our approach really shines, when we can run high throughput calculations, when we can quickly source the data and have it in a database ready for analytics and some sort of artificial intelligence. So let me talk now about the collaboration and the way that we establish it. First of all, as you can now already understand, we have multiple accounts that are available to the platform users. And in order to be able to utilize those accounts, I can navigate to the My Accounts page. So I open the right-hand sidebar, click on My Accounts, and now I can see the accounts that I have access to. That's my personal account at the top. Everybody has one personal account that identifies them as a person. And they can have access to multiple organizational accounts. So I can be a member of multiple organizations. As you can see here, I'm a member of exabyte.io account and a member of the seminar account. So now I'm going to start using the platform through the seminar account by clicking on it. All right. And I can see the entries for materials, projects, workflows, jobs will all correspond now to that account instead. All right. all the information have changed accordingly. If I want to come back and use it, use the platform through my personal account, I do the equivalent steps again, come back to the page, my accounts page, and click on my name. And now the entries have changed to reflect on my personal items. Within the organizational accounts, we dedicate permissions using a role-based permission scheme, and we facilitate this role-based permission scheme through teams. So we can add members to the organizational account by selecting users by the username. So all users of the platform are searchable there, and we can add users to the account this way. Now, once we added them into the account, we can also create a team and allocate a certain type of permission to this team. So in this case, I'm going to create a test team, and I will give it the read permission. Right? So now we have this test team with read permissions. Next step, we can add members to this team. If we navigate to the Teams panel, open the team, we can add people into the team in an equivalent way as we did before. And now the people that are members of the team and organization at the same time, they will be able to have read permissions on the items that I will add to the team on the next step. So next step is to add the items like materials to this team. This is what we do. So now the members of the team have read permission on the material that I've just added. And that's the way for us to facilitate role-based permissions on the platform items. Now, the access levels for the items themselves can be controlled separately. And to do that, we can allocate access to either a single account by default, or we can share entities between accounts in the platform directly. We can share entities with all the accounts in the platform. So anybody who is logged into the platform will be able to see the entry. We can share an entry with anyone who has a link. Even if they don't have an exabyte-io platform account, they can still access it. And we can make an entry shareable and visible for search engines online as well. That's useful for publications, for example. And here's how we do that. When we select an entry, we can click on Share Item at the top and select another account, just like I did before, and give it a read permission. If we want to share the entry with all the accounts on the platform, we select public instead of a particular account, and public represents all users of the platform. If you want to share it with anyone who has the link, we select anyone with a link. And accordingly, if we want to share it with anyone on the web, we select anyone on the web. Right? So now when we navigate into this entry, you can copy the URL from the browser and share it directly with other people. To be able to access the entities that were shared with other accounts directly or shared publicly, we have two shortcuts in the left-hand sidebar. And accordingly, we show the statuses for the entries in the table, right? So if you navigate to the Shared with Me panel and go to the jobs, we are now able to see the job that I just shared with the webinar account from my personal account. Okay, here is how we do that. In more details, we go open the left-hand sidebar, navigate to Shared with Me, open the Jobs panel, and there we go. You can see the job that I created through the seminar account that is now shared with my personal account. It's accessible to me. If we navigate to the Shared Publicly panel, we can see all the items that were publicly shared. And there are quite a few of them as we have more and more people joining the platform. There are many items that they create. So we might need to extend the number of entries in the list to be able to see them appropriately. Like that's what I'm doing here. I'm looking at the first 50 jobs that we're tracking. And we can see some of the latest calculations. Some of them are still in progress. And we can see the snapshot of the system at this point in time. As we collaborate on the entities in the infrastructure that we allow users to access, it is convenient to add descriptions to the entities. And we can do that by navigating to one of them and using the icon here, the information icon, to add a description. Here's how we do that. If you click on that icon, we are presented with a menu where we can type a description, and we can use Markdown to be able to adjust the format of this message, include links and source code and things like that. Now, after we modify this description, we can view it inside the list by enabling the ID and description column. So if we have a list of jobs, we can see their corresponding descriptions. And the same is true for materials and workflows. That's a quick way for us to understand what happened in each of these entries when we come back to them, for example, in a few months after they've been created. Okay, so that's how we can add commands. We can communicate and exchange information between multiple people, for example. As I mentioned before, we have a way to track all unique entities in the platform. So when multiple accounts create equivalent entities, we track unique items inside the entity bank. And we have entity banks for materials and for workflows. And when accounts subscribe for a certain public, certain service level that allows for private data, then no other accounts can access the corresponding unique entities in the materials or workflows bank. And by default, and for those people who are not sensitive with their information, other accounts can see what they do, and they can collaborate and leave commentaries and exchange information this way as well. Okay, so here's a quick summary about accounts and sharing. Entities can be shared within one account and only that account for a secure and safe collaboration. Account teams have different permission schemes and allow members to perform different actions on these entities according to these permissions. We have sharing enabled between individual accounts and between all the platform accounts at the same time, external and non-registered users as well. The entities support metadata like descriptions and tags. And this metadata can help users find entries and exchange information as well between each other. Unique entities are consolidated using entity banks. Okay, so this is a quick overview of collaboration in the exabyte.io platform as it is today. If there are any questions, I'll be glad to answer them. I do not see any questions as of this moment. Okay, doesn't look like any. So with that, I'd like to thank everybody and wish everybody happy holidays and stay safe and well. And looking forward to our next session in 2021.